Hello everyone and welcome to this video. We will be solving using the fourth order Runge Kutta. So yeah, here's the formula. Actually, actually they are formulas because we now have this K1, K2, K3, and K4. If you watched the few previous episodes, when we discussed the what we call as the Ralston method, that's a second order Rungekuta actually. So here is the fourth order. So we have y sub I plus 1 is equal to y sub I plus 1 over 6 of k1 plus 2 k sub 2 plus 2 times k sub 3 plus k sub 4 times the step size, where the k1 is the function of x sub I and y sub I, and the k sub 2 is equal to the function of x sub I plus 1 half of h and y sub I plus 1 half of k1 times h. K sub 3 is equal to f of x sub I plus 1 half of h and y sub I plus 1 half of k squared, actually k sub 2 rather, value for the y as 1, and our step size is 1. So at our I is equal to 0, we have this y1, y sub 1 is equal to y sub 0 plus 1/6 of k1 plus 2 times k sub 2 plus twice of k sub 3 plus k sub 4. So we have the value already for the y sub 0, which is the initial value, but we don't have values for the k sub 1, k sub 2, k sub 3, and k sub 4 yet. So we're going to solve it using the formulas given. So the k sub 1 is equal to this formula, and we'll be having these initial values of 0 and 1. Therefore 0 squared plus 3 times 1 is equal to 3. K sub 2 is equal to this formula. Substituting the values, we have 0 plus 1 half times step size 1, and 1 plus 1 half, then the k sub 1 is 3, so 3 times the height, or actually step size. I usually get confused with the height and step size because of the letter h. I'm so sorry. So this is the step size, so that's 1. So we have now the function of 1 half and 5 squared. Actually 5 halves. I'm getting confused now. So substituting this here, x squared, so that's 1 half squared plus 3 times 5 halves, we'll be having the value of 31 over 4. Same goes for the k sub 3. We have a minor differences between the formulas for the k sub 2 and k sub 3, but that's the same step. And so for the case of 4, we have this different formula, and substituting the proper values, we'll be getting the answer 389 over 8. So inserting the values here back on our main equation, we'll be having this 1 plus 1/6 of 3 plus twice of 31 over 4 plus twice of 119 over 8 plus 389 over 8. Okay, simplifying 775 over 8. Okay, times 1/6 plus 1. So we have the approximation of 823 over 48 for the y sub 1. So that's nearly 17.14, or actually 17.14, 5833333, and so on. So that's for the fourth order Runge Kutta. And at this point, I think we have just solved it.